we will look at topic 4 notes. So please take it up now. Okay. Yes, we are almost at the end. And the end means that there will be a beginning somewhere else. So topic volume B notes will come in next Tuesday. Volume B notes will come in next Tuesday. So can you get someone go with you next Tuesday to take the notes from the reading of it? You need 2 muscular guys. Volume B is thick. Okay, so you need two muscular, no, not muscular side, muscular people. You can be try and Jukai for you. Okay, yeah. Okay. Or Jaden Lawrence again. Edison Fu, yes. Oh, Edison cannot. Whoa, look at that. Oh, where put the Singapore life jacket trying to flex to me. Okay, so let's go to question 3. Okay, have I gone through this yet? I have started. I just have not done. Where are you all now? I just check. Question 3.3, 3.4, 3.1, 3.2. Where are you at? 3.4. Who's at 3. Anyone? 3.3? Anyone? 3.3. Area where are you at? 3.2. Okay. Ethan, where are you at? 3.2. Okay, let me start from 3.2. Slowly. Okay, let's continue from here. Slowly, no rush. Okay, can I suggest 3.4? You all do it the last. Means after 3.3, you're going to do 3.5, 3.6 first. 3.4 a bit hard. Yeah, I scared you all demoralize. So 3.4, you leave it to the rest. 3.4, you all see the question got Mr. Jason Lee flavor inside. So, okay, you after 3.3, you all jump to 3.5, 3.6. Okay, 3.4, you do it last. Can I? Okay. So, question 3.2. Okay, let's do it slow and steady. Question 3.2. Okay. I'll just say a few things. If you want to listen to me, listen to me. If not, just you can follow your own prompt, all right? So question 3.2. Okay. Now, if I want to solve exactly, I know that this will probably be a quadratic graph, right? I know that this will probably be a quadratic graph. Okay. So this graph, right? I'm just guessing it's going to look something like that. Okay, so maybe what I'll do is I first consider x squared minus 2x minus 25 equals to 0. Okay. Then I realize that it's not factorizable. So what I do is I look at the formula. Okay, guys, just again, reminder, if can 3.4, leave it to the last. Okay, because I want you to feel sense of achievement. You do 3.4, 3.6, you feel happy. Then 3.4, you'll be wet. Okay, so 2.4, do it the last. Okay, so then I solve negative b plus minus square root b squared minus 4ac over 2a. Okay, what do I get? I think I will get 1 minus square root 26. 1 plus square root 26. Okay, so I'll get 1 plus minus square root 26. Now I look at the coefficient. The coefficient is positive. That means the graph will probably look something like that, which is like 1 minus square root 26, 1 plus square root 26. Okay, if you're not this question, don't worry, you don't need to listen to me. Okay, just go at your comfortable. Okay, so if I want it to be less than 0, right? If I want it to be less than 0, that means I basically want this portion. Of less than 0 means I want this portion. Okay, so I will be looking at x with 1 minus square root 26, 1 plus square root 26. Okay, that's the idea for part 1. That's the idea for part 1. Okay, I'll just pause here a while for you all to, for those who are doing part one, to continue with part one. Yeah. Correct. Good. Huh? Yes, yes. But then when you modulus, you will reflect back. So what you are drawing is correct. It's correct. It's correct. It's correct. What she waving at? Give is at 3.5. Ah. 3.4 you do last time. Anyone's at 3.2? You're ready to do part two already? Part two already. Part two already. Okay, so then after that I'll draw the graph. Okay, so you can see if this is the graph, right? It looks like that, right? Then if I'm drawing a modulus, right, what will happen is it'll become reflected. Oh, it'll become reflected. It'll become reflected. Makes sense, makes sense, So it'll become reflected. So after I'm going to reflect, but let me just show you the nicer one. Because I draw graph very hard. I won't show you the reflected one. Okay. Now then, of course, when you are building the reflected graph, make sure you put the x and y intercept. X intercept you already know. Y intercept, well, just sub x to be 0. Just sub x to be 0. Right? You will get the y intercept. The y intercept is here. To find the mid turning point, you can see how, JH, when you were in JH2, right? The turning point, you can take the middle, x1 plus x2 over 2. Here, I'll give you a it's like 1. Right? 1. So this is, you can see, 1 minus square root 26 plus 1 plus square root 26 is basically 2 over 2, which is 1. That's how I get 1. Okay. So of course, there are also some students who say that this equation is the same as x minus 1 square plus 26. That is fine as well. Sorry, minus 26. That's how they got the turning point as well. That's also okay. Just by completing the square. Learn intuition. Okay. Most important, if you are forget the x percent, y percent is okay lah. It's not good. Most important, you know the shape. Especially with this chapter, you know the shape. You know that you succeeded. You learn something. Okay, So I will pause a while. The Desmos will help you. Actually, this Desmos. Let me switch question. Are you at? Which is this one? Which is this one? Negative b over 2a. Which question are you at? You can try on. No issue. So then after that, okay, what do I want to do, right? After I got this graph, right? Okay, so you see the graph will look something like that. Wait, let me check. Anyone need to copy? I observe your body language. If you all look at the screen, then you all look down and write down and say, wow, okay. That's not. After that, why part 3, right? Part 3, you just need to find how many times the horizontal line cuts the graph. How many times the horizontal line cuts the graph? Yeah. Two different graph. Meaning you're drawing modulus x minus a and a square over x minus a. Two different graph. So the graph is like that. V shape, the standard V shape. This is your 3.1. You look at your 3.1, it's exactly the same shape. Oh, okay. Modulus. It's minus a. So the 1% a negative because it's modulus. Okay, so y equals to x minus a, right? It will look like, okay, let's assume a is positive. Like, if I think of gradient is 1, right? So it will look something. Yeah. Okay, so this will be a, this will be like negative a. Oh, so but if it's a modulus, right? Okay, so I show you on the modulus. What happens? Like this. Negative a will become a. It's a reflection in the x-axis. Now, not one. Okay. And I will do the don't have to like this one. Yeah. The dots. My advice is to draw. My advice is to draw for learning. No, exam not doesn't matter. Okay. Okay. So now, yeah, okay. So now I go on to part 3. So part 3, okay, standard lah. So you see before start question, find the number of solution, aka is the number of intersection. So if I look at, for example, if I were to look at this graph, I look at this as like my first function. I look at this as a horizontal line, y equals to 10. I'm just trying to find out how many times they intersect. How many times they intersect. How many times they intersect. Okay, so if I look at the graph, okay, I give you an example. Okay, let's say my graph looks like that. Okay, let's say my graph looks like that, right? Okay, so you see, if I put y equals to 10, this is my second graph. My first graph is this. How many times do they intersect? How many, Bias? 4, right? Can you see? 1, 2, 3, 4. Can you see? 1, 2, 3, 4. How many times do they intersect? 4. How many solution? 4. Huh? Yes. Okay, so that's why, Javier, your question, right? You realize they ask you part 1. Part 1 is to help you to part 2. So you start from A over X. Okay, Javier, the graph, right? You start from y equals to 1 over x. You start from here. And I hope you are okay. Now I think you got the two transformation. One is scale by vector a squared parallel y axis. One I think is scale by a unit. Positive x. What does the scale if I scale a square, right, all the y coordinates will multiply by a square. If I scale factor 2 means I times 2. You try put a as a number, you see what you get. Okay, I hope the rest is that. Okay, so now I go back to question 3.2 part 3. All agree? I got 4 answers because I cut 4 times. Okay, this kind of question, very standard one. NJC, I think every year 10, 6 or 7 times. So this is one function. This one is another function. What's the number of solution? What's the number of solution? It's the number of intersection. Okay, okay. So now, if I look at the equation of tangent at x equals to p, where 1 is equal to p, have you all tried this? Who has done part 4? Who actually can do part 4? Wow, very good. How do you do it? Between 1 and 6. It's an answer to it. Because of that, you just explain for it. So
my answer is like all over the place.
can you explain?
But basic.
Can't see it. Sorry. My bad. Okay. Okay, so because P is between 1 and 6, you were saying? It's a W, correct? So is it in the center part or the sides? Is it the middle region? Look at the side. Okay. Now, if you look at here, right? P between 1 to 6, right? For P between 1 to 6, right? Are you talking about the one in green or the one in pink?
X would be like 1 plus square root of 6. And then dy dx is 2x minus 2, but because x is like bigger than 1, is between 1 and 6. So then the dy dx is always bigger than 0.
Okay.
And then, so like this, like that.
So how do you find the gradient function? You differentiate a modulus or
Differentiate for dy dx and then I just sub the value to it.
just sub the value in?
X minus 1 minus 6 times.
You mean not the answer, but for. Okay. Just check. Question 3.2 part 4. The answer y negative 2p plus 2x plus 3 squared plus 25. Those who did you get this? This side. Okay, very good. But how do you do? How do you do yours? Guys, listen to Timothy.
Which means
The negative of fx, correct. Okay, correct. Okay. Who else can do? Yes? Oh, waiting for me. Oh, I thought you want to ask me something. So I look at you. Okay, so basically 2 people have given the good answer. Okay. Now, if I want to find the equation of the tangent, okay, so I'm looking at this part. You all agree with me that if I'm drawing the graph, right? The graph looks like that, right? Can I say that this part that is in green, it will be positive fx, since it's already positive, and this part that is in blue pink is actually negative fx. Can I say that? Okay, why do I say so? Because by our definition, modulus of fx can either be fx or the negative of fx, right? When is modulus equals to itself? When f is non-negative. Very good. When is fx equals to the negative of itself? When is modulus fx? When is this equals to this? When? Yes, when fx is negative or when fx is negative. So now you all take a look, right? If I consider this as my fx, the original fx will look like that, right? Okay, so you see the part that is in green, right, is basically this portion. Okay, fx modulus is equals to this, right? But if you look at modulus fx, right, why is it negative? Because you can see that the original fx is reflected. So this part pink is actually over here. Your feel what I said so far? But because fx originally is negative, that's why reflected. So I got this answer. The part in pink is here. That's far. Yeah. Now, why do I say this? Is because you will find later on, carry on business as usual, and you want to find the equation of the tangent y minus y1 equals to gradient x minus x1, you will find that you have issue with the gradient. Because how I differentiate modulus? You don't know, ma? Okay, Now for P between 1 and 6, where is that? Is it the pink part portion or the green color portion? Shenhan, you were saying? Very good. So 1 minus square root 26 is here. 1 plus square root 26 is here. Square root 26, I think, is 5 point something, right? So 1 and 6 is probably somewhere around here. So this is where 1 and 6 is. So far, okay? Lloyd, stop looking at your. What are you doing? Look like you're flexing your bicep. For P between 1 and 6, right? Modulus of fx is actually negative of fx. So what I'm trying to say is modulus x squared minus 25 is negative x squared plus 2x plus 25. Do I manage to convince you on this question? Yeah, can go ahead. Oh, I thought you were oh, nice. You don't forget your module. Oh, yeah, right. Okay, can okay, so once you got this one, right? Once you got this, now I ask you, can you find the equation of tangent? Can, right? So now you know this is my fx. Okay, Why is now sub x equals to p? What is your f of p? It will be negative p squared plus 2p plus 25. What's the gradient? F prime x will just be negative 2x plus 2. Right? F prime p is negative 2p plus 2. Okay. Now, because you see, why do I need to do this? Because you need gradient for equation of tangent. So, guys, this is your x1. This is your y1. This is your gradient m, right? You all remember equation of tangent is y minus y1 equals to gradient m x minus x1. Okay, that's doing all this. Why do I find f prime x? How do I find f prime x? Okay, so you see, because I'm doing it by differentiation, right? So if you remember topic 2, usually how we find a gradient is we differentiate, right? But so Alan, I come to this equation, shit, how I differentiate? It's modulus, fair enough. So that's where you realize that's where I try to unpack. Okay, modulus, never mind. But if I unpack the modulus to 2 scenarios, right? I know that when P is between 1 to 6, right? The modulus is actually the pink region, which is the negative of itself. So I unpack for you that this modulus is actually the negative, which is actually this function. Now if I give you this function, can I differentiate? Can. Negative x squared will give me, okay, so if I differentiate negative x squared, I'll get negative 2x. I differentiate 2x, I'll get 2. I differentiate 25, becomes 0. So this is the gradient function. This is the gradient function. So if the gradient function, then remember equation of tangent is what? Y minus y1 gradient x minus x1. Correct? You want to find this at x equals to p, right? So this is your x1, can you see? This is your y1, can you see? This is your gradient. So you just sub inside and you get over here. And it's very disgusting. Yeah, go ahead. Yeah. And this is question 3.2. You try to digest. Yeah, slowly touch. So it makes sense to you. Those who don't know, please ask. Ask until you are satisfied. Doctors, okay? Are you all right? So, okay? 3.5. 3.3. Okay, I'm getting there. Do you have trouble with the graph? The graph, right? Huh? Yes. 3.5, I think, or is it 3.4? 3.5. 3.5, the answer is a range, you know. 0 to 2 and 2 to 6. 0 and 2 and 2 to 6. Part 5, right? 3.5. Part 5. Or x between 0 and 2. And x between 2 and 6. Okay?
That's why.
That's y, right?
Why means
Let me check it. Okay. Anyone need me to repeat? To pass. You were at special the last lesson. Okay. Give me a while. I have the rest of the okay. Okay, so I go to 3.3. Okay, 3.3, right? Hold on, not that. You just need to be patient. Okay, so 3.3. Okay, if you don't know, you can use decimals to help you. All right. So if you, yeah. Okay, so 3.3. First, if you drop, okay, I always start from something I know and then I build it. Right now, that's how you start. Now, if you have first, do you remember how to draw y equals to 4 power x? Is this hand, right? Your hand the right line, right? Is this line, right? Right now. So it's this line that goes like that. Y equals to 4 power x. And that's an asymptote, which is y equals to 0, aka the x-axis. Now, if I'm drawing y equals to 2, so if I'm drawing 4 to the power negative x, this is what it will look like. Okay? I'm drawing 4 to the power negative x. Remember, when we replace x with negative x, what happened? It's a reflection in the y-axis. Okay, it's a reflection in the y-axis. So if, first of all, you know 4 power x, you draw y equals to 4 power negative x. It's a reflection in the y-axis because you are replacing x with negative x. I want to use your transformation knowledge. Okay, now after that, how do I do 2 for negative x? I'm replacing y with y over 2. Okay, so why is it a scale? It's a scale by factor. It's a scale by factor. 2. Oh, very good. Parallel to the y-axis. Okay, that means basically what will happen, all the y coordinate will times 2. This is originally the coordinate 0, 1. Okay, now this graph here, graph number 2, this is graph number 1. This is the same as, sorry, this is 1, this is 2, this is 3. 1, 2, okay. Graph number 3 will look like that. It will go up higher. Sorry, wrong. It will go up a bit steeper. This is y equals to 2, 4 power minus x. Instead of 0, 1, it will be 0, 2. But intercept asymptote stays the same. This is graph number 3. Okay, I want to be as granular as possible so you can see. Graph 1 is over here. Graph 2 is over here. Graph 3 is over here. You all follow so far? I pause a while for you to digest. Okay, but guys, don't worry. You can use your decimals to see. I'd rather you do your decimals, then you try to figure out why, rather than you don't know how to start. Okay, at least you got decimals, you can start something. You finished 3.5, 3.6 already. No. Oh, I asked you to do this one last. You never listen. Okay. I said trip. Yeah, I said just now. Hey, how come you are here today? See, you change place. How come? Huh? Jason got headache over here. Why? Because is it my voice too loud? The smell. You see lah, you. Okay, horrible. Okay, so now, after that, I will do graph number 4. Graph number 4 is 2, 4 minus x minus 1. Minus 1 means what? I'm going to basically replace y with y plus 1. What's happening here is I'm translating 1 unit in the which direction? Anyone can help me? Negative? Negative? Huh? Thank you, Braden. So this is graph number. Let me extend some more. Graph number 4. Graph number 4 goes down even lower. Okay. In fact, I can shift down here. This is graph number 4. Graph number 4. Okay. Sorry. Graph number 4 will shift down. Are y'all following me so far? How come I feel so lonely? Huh? Why is it not the same as 2? It's the same direction as 2. But here, okay, because I'm doing a minus 1. So 0 become 1 0. 0 2 becomes 0 1. Because from here to here, I'm translating 1 unit negative 1. Remember? You're the one that said negative 1. So after all that we have been through, this is the graph. Okay? Yeah. I'm just showing you how to do it yourself. Okay? I'm not trying to teach you anything that's modulus. I'm actually teaching you graph transformation. Okay? But you will realize that, okay, I'm not done actually. There's still a modulus. Okay, there's still graph number 5. Right? So graph number 5 is what? Graph number 5 is to finally package everything inside the modulus function. Okay, so modulus is not really a transformation. So I go to graph number 5. Okay, I know Sipong is actively paying attention. So this is graph number 5. Graph number 5 is so beautiful. Yes, y equals to 1. Because y equals to negative 1 is brought backwards. Okay, and this is still remaining as half. This is still remaining as 0, 1. Y equals to 2 power 4 minus x minus 1. Okay, ladies and gentlemen, 5 graph to get you down. Yeah. Modulus, sorry. 0.1, sorry? It should be at the asymptote. Oh, yeah. Good eye. Well done, Jaden Lloyd. 1,000 points for you. Very good, Jaden Lloyd. Good observation. Okay, because this is y equals to y, the point is negative. Okay? Can I? So I'm just going to stay here for a while so that y'all can absorb. Okay, sorry there's so much talking because there's a lot of steps I want to make sure y'all are clear. This question you see brings together a lot of things like transformation, exponential graph, 3.5. Yeah. To 360. So if it's 3, right, there's a 3 there, it's 360 over 3. Yes. Three 3.4 part 3, the answer x less than a or x more than equal to a. Got it, huh? Good job. Happy for you. More than equal to a. Happy one for nothing. Don't be so emotional, it's just math. Math doesn't take everything in your life. Yeah, question 3.4, I can't really write the answers down. If you don't mind, I'll just walk around on you all for a while. Yeah. Oh, are you okay? How do I use the? Oh, this one, huh? How do I use? Okay. Okay. So you see this one, right? For it to be more than 0, right? Okay. So you see this one. For this to be more than 0, they got a lot of way, lah. Got a lot of way. Once I use the graph. Use the graph. Can you see when you see more than 0, x must be less than half. Because for it to be more than 0, right? More than 0, basically you want the top part. Oh, so you see x must be less than half.
Yeah.
Fair, right? Or all right. So sorry, I missed it. Question 3.3. There. Yeah.
What is argument for negative?
This one. This one. I also don't know. Give me a while, later I see. Let me get it. My brain not there yet. So yeah, both are increasing function. Because the base is more than 1, remember? If the base is more than 1, I take away the base is okay. Okay, J3. Remember, if A is more than 1, then A is more than A power y. If A is equal to 1, this is one result. Then A, this will be more than, this will be same. If the base is more than 1, like this case, the base is more than 1, When we remove the base, the inequality is X. Because this is an increasing function. Okay. But the base is, that's why I have yeah. You can even do this. You can even do this. You can even say log both sides. You can do that. Negative x log 4 more than log half. Negative x more than log half over log 4. So this one, this you can calculate. It will just be. This is the same as log over log negative half. So negative half. Anyway, whichever way you like. Yeah. 3.5. My brain not there yet. Yeah, but okay. 3.5 which question? Part 5. X. It's a typo. It's a typo. So it should be K. It should be K. Yeah. Yeah. 3.5. Oh my god. Yeah. It should be K. So sorry. So sorry. Yeah. So because we don't usually test for X, we test for Y. Yeah. Makes sense, right? Yeah. Okay, so is 3.2 okay, everyone? Okay, sorry, now I go to 3.3. Is 3.3 okay, everyone? Okay, so those who saw thanks Ariel for pointing out I missed out the first part exactly. So yeah, solutions are here. Solutions for many ways I wrote the board also. So I forgot I missed out. Yeah. Got it. Okay. So okay, if the base is more than 1, right? Then if I have this inequality, I can remove the base. The inequality still stays the same. Correct. So the inequality will swap. So then I go to question 3.5. I'm going to skip 4 first. I come to 4 next week. 4 is just so hard. I look at 4, I think I feel like I need to drink a bubble tea before I do. Okay, so are you okay? Your 3.2 okay? So we can take so anyone is at 3.5? If you are 3.5, can you just take note? Part 5 change to K, not X. Part 5 change to K, not X. Between 0 and A. Part 4. Okay, 3.4, 3.5, 3.4. Really, man?
Because like it would be
the graph looks like that. Okay, 3.4 looks like that.
That and the other one. Then they only intersect between like 0 and A.
0 and A.
Because it's gonna be like it goes
Oh,
down.
yeah. Yeah, you're right. This one is wrong. Very off. Yeah, you're right, you're right. The X is between 0 to 8. Yeah. Next one. 0, right? 0, right? I also think so. Because we saw this two portion. Okay, okay. I go to 3. Yes. One second. When is modulus more than graph? So I want the modulus. Shouldn't it be this part? Part 3, right? Modulus more than graph. Modulus more than curve. Modulus more than curve should be here and here. These two, right? So modulus more than curve. This point is 2A. Sorry. This point is 2A. Oh, so you can see this portion is x more than equal to A. This part is x less than A. You want the modulus to be above the curve. Okay. Question 3.5. Is 3.5 okay? Doctors, where are you at? 3.4. Oh, 5, 6, you are done. 6 not done. Challenging question? For 6, for 7. 3.5. Who is done with 3.5? Okay, maybe I'll let you all check answer. 3.5. Amplitude is 4. Period is pi over 3. Graph is below. Graph is here. This is the graph. Then after that, you need to draw the modulus. I think you can see the graph and the modulus are on the same diagram. So sorry. It's just okay, so like the graph is here. The graph is here. But the modulus is just like that. Okay, because this question they say on the same. So I have to follow. But it's okay lah. I mean, now you don't go and erase. It's just for them. Now, when will you have 4 solutions? State the values. This one should be K. This one should be K. This one should be K. Remember just now I say. Okay. Okay. So when we have 4 solutions, look at this as a second y function. Look at this as the first y function. Right? Y equals to K is what kind of line? A straight line, a horizontal straight line. Very good, doctors. Clear and sharp. Okay, so when do you want 4 intersection? Here. 1, 2, 3, 4. It's between 6 and 2. Between 6 and 2, you will see that any horizontal line will cut 4 times. Okay? So if it's at 2, you will cut 3 times. Between 2 and 0, okay, you can see also you'll cut 4 times. Okay, that's why the answer is between 0 and 2 and 2 and 6. Okay, can. Yes. Triton sign is the member. Is the you all learn in set theory, JH2. This one means member. This one means what? Union. Very good. Yeah, but you use ruler lah. No, they cannot be equal. Cannot be equal. Equal is yes, that's true. Good. Okay. 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 So I will stop here. What the toilet? Later. Don't think I don't know. You all sign outside, then you start toilet, then you all go toilet together. Yes. Okay, if you find this one, right, the minimum value, this is between -4 to 4. Correct? Because it's a sine function. This is between sine is between 1 to -1. 4, then you'll be 4 and -4. +2, then +2, +2. So it's -2 to 6. Fair? Fair. Okay, on Monday, I will go through practice set 3. Clear? It's only 4 questions. You will see that the homework set got 5, but I give discount. Okay, partly by mistake. I forgot to take photo last question. So only 4 questions. 1, 3, 9, 11. Okay, very easy one. Okay, today I went to 4, half an hour is easy. Yes. That's it. I need to go. I need to go. Okay, I just show you. Ready? 1, 2, 3. 1, 2, 3. Thank you, class. Okay, thank you, class.